real-time data and web apps with Node.js. Brief safe harbor statement. Whatever you do, don't make any purchasing decisions based on what I tell you today. All right, so here's a high-level overview of the agenda. We're going to talk a little bit about how we got here, a little bit about where we're kind of at today, and then I'll talk about mixing in the database. But before I get to any of that, I want to do the demo first. We're going to get this out of the way early, and what I need from you guys is a little bit of help. I'm going to show you a URL, so I need you to take out your cell phones, tablets, whatever you're using, or laptops. And when you get the URL, go to it and start some voting. So I'll tell you a little bit about what I did here. So I found this website. I just kind of Googled most livable cities or best cities, something along those lines, and I found this website. It said these are the 20 greatest cities to live in. And you can only see the images here, but I just kind of scraped this list and went ahead and put them in a table in a database. And so you can see the list here. Now, like 5, maybe 6 of these cities were from Germany, so obviously the author was German. But I didn't think that would be a lot of fun here, so I went ahead and deleted some of the German cities. I did leave Munich, because of course, Munich, right? But now we have Warsaw, and I've also added Krakow, and of course I had to add New York City because that's where I call home at the moment. So, I'm going to have you come to this app in a minute. Trying not to show the URL so much right now, but basically what this is those cities. And you're going to come here and you're going to vote. You're just going to click a button to cast a vote. And hopefully this actually works. Yay, okay. So Amsterdam is currently winning with 1 vote. Everybody else is tied for second. And so, yeah, you just come in here and you start casting votes. I'm going to be on this other page, this dashboard page. And so you're now seeing the URL I want you to go to. It's bit.ly/ this is for Code Europe Poland 2017. And yeah, so I'm going to hang out here on the dashboard page. And what we're seeing is the total number of votes submitted on the left. And over on the right, there's updates pushed. And we can see all the cities. And once we get some votes starting to roll in, then the games will begin. Oh, hey, look at that. Warsaw's now in second. Amsterdam, ooh, must be some folks from Amsterdam here. Krakow's taking the lead. I'm actually kind of surprised about that. Aren't we in Warsaw, folks? Wow, Krakow's really killing it with Berlin. Whoa, I didn't know there was some German folks here. I apologize for deleting some of your cities. Ooh, Copenhagen's coming in strong with Krakow still in the lead. Tell you what, well, keep an eye on this number, right? So total votes submitted, obviously going much higher, much faster. And we got updates pushed over here. While you guys are rocking the vote, I'm just going to go do a little database work over here. Oh my gosh, Warsaw just took the lead. Cool. All right, so anyway. Any SQL folks in here? Maybe a few. So what I'm going to do is insert into, and there's this table here, super city votes. And I'm just going to insert into the city ID column. And what I'm going to do is select 15 from dual, which is a fake table, where row num is less than, looks like I'll go with 10,000 for now. So I'm going to fire that off, just 1 row. Why is it only inserting 1 row? Well, let me commit that. Let's see if it's really just 1 row. It is indeed. Ah, I see. We need to do a connect by there we go. Now I commit. Holy smokes, folks, New York City's taking the lead. I don't know how that happened, but really quick, while the timing's right, I'm going to go ahead and just enable a trigger here. And this trigger will effectively stop the voting. And, hey, New York wins. Cool. At precisely 12:04, the crowd turned on Dan. So we can actually fix this Oh, you know what? I'm just going to leave New York in the lead. Cool. So thanks for participating. I appreciate it. And what I'm going to do is kind of talk about how I put this demo together, and then come back to this number over here, updates pushed. All right. So we'll start by talking a bit about how we got here. For a little bit longer, we're going to be in 2017, so it was 20 years ago still that HTTP became a thing. Prior to that, it didn't exist. And HTTP then and now is still a very simple request-response protocol. So in the beginning, the web browser would issue a GET request, usually something like that, to a web server. Web servers at the time, something like Apache. It would generate what was often just a static file read and send that HTTP response back out to the browser. Over time, though, we realized we could do a little bit better. We could involve a database in the mix. And so the way that would work, the web browser would still issue the same HTTP request to the web server. The web server would then use some kind of driver-based technology to communicate with the database. And the database would respond with the driver, with the data, and then the web server would generate that dynamic web page and send the response back out to the web browser. And that's cool. I know some of you folks are like, actually, Dan, the work we do is a bit more complex than that. We use transactions. And you know what? Now that we're thinking about it, we have to shard our databases because we're a global company. And in fact, in the mid-tier, we're scaling our Node.js servers based on memory and CPU utilization. And we're doing all that because we got a whole lot of users. And at the end of the day, our network traffic ends up looking a bit more like this. I get it. This is kind of like what folks are dealing with today. But for the purposes of this talk, we can keep things simple. Just keep in mind, you can scale up to that if necessary. It always just needs a few more lines of code to get there. All right, so at this point, you could say that, in effect, the browser is currently sort of like a cache of the database, right? The database serves some data. They're now viewing the data here, and it's like a cache. But then what's going to happen, right? Somebody's going to come in, and they're going to issue an update statement in the database, and now you have a stale cache here. And so the question is, how could you get this to update and reflect the latest and greatest changes? Well, for the longest time, and we'll talk more about this in a bit, we've had the ability from the database to let the web server know that there was a change to data and that it needs to update the cache. What we've not been able to do is to then kind of propagate that from the web server to the browser. We couldn't do that for some really good reasons related to security. It'd be kind of scary if web servers could just tunnel into your browser without you wanting them to. So it took a little bit to get there, and in the meantime was this quest to simulate that kind of a thing. Now, be honest, raise your hand if you're guilty of any of these. Come on, I'm guilty of all of these. I've done all of them. So the forever frame was the original way to do it. You would hide an iframe and the actual page you're displaying to your users. You'd use the iframe to go to your web server and get some new data, and if there was new data, cool. Proxy that up to the parent page, update the DOM, you're off to the races. But then, and we like to give Microsoft a real hard time, i.e. that kind of thing, right? They actually invented AJAX. So we owe them a bit of thanks for that. We got AJAX polling. So now you would do something like a set interval, and you're occasionally just going to the web server and you're saying, hey, you got new data? Hey, you got new data? Hey, you got new data? And every time you're doing that, of course, it's oftentimes going to the database, seeing if there is a change in data, not very efficient, full round trips, but it was better than what we had before. Then along came AJAX long polling. This was a bit better. You're going to the web server once. Hey, you got new data? And you don't end that request. You wait. And the web server can then just leave the request open. When new data does occur or change the data, then it will complete the request, send the response. So the latency was cut in half because now it's just, the end of the response, and you're not continually asking unnecessary questions. Step in the right direction. Then we got HTML5 server-sent events. Anybody ever heard of those? Yeah, I'm not surprised. Not very many folks, because what we got shortly thereafter kind of stole the show and no one really ever learned about them. So that brings us to where we're at now. Some new technologies have emerged. We have WebSocket and we have WebRTC. Now, this being a talk on real-time data, you're probably thinking, real-time communication, I'm probably using this technology. That's not the case. This is really great and very cool technology, but they're two different use cases. And so WebRTC is all about connecting clients directly, cutting out the middleman or the server in our case. This is great technology if you're doing something like streaming audio or video, like a chat kind of application, or especially good for gaming, just sending arbitrary data. You certainly don't want the latency of going through a middleman. But for something like what I was doing, you're casting votes, and all I need to do is kind of push an update out to from the server to the browser, this is where WebSocket really shines. So it's all about enabling that bidirectional communication that we didn't have before. And it's great because it works sort of just tunnels in through HTTP. So all the normal networking protocols we're used to work fine. It goes right through, different kinds of proxies and whatnot. And we get the updates we've been looking for. Now, another reason you might shy away from WebRTC has to do with browser support. So I've been watching this kind of change over the last few months. There's a lot more green than when I first started doing this talk. But if you're still, having to support IE11, WebRTC is not going to work for you. What I usually pay attention to is the number in the upper right-hand corner here, global support. I wait till it gets like above 90 before I think it's, kind of safe to use in the wild. And this one's still at 74%. But if you look at WebSocket, it's at 94%. So there's a whole lot more green. Unfortunately, if you have to support Opera Mini, it's not going to work for you either. Have to use something like long polling. Cool. So once you've decided to use WebSocket, this is the kind of thing you might get into. So here we have some code that shows how it works. So on line 2 here, we're declaring a variable called socket, setting it equal to a new instance of the WebSocket. And you just pass in the URL where the WebSocket server is listening. Then you have a socket instance, which is an event emitter. And so you can set up some event listeners. One here is on open. And when this one fires, you're going to get an event. And you can use that to send data down to the server. Cool. Conversely, when the message event happens, this is the service trying to tell you something. So when you get that event, you can access the data property to see what kind of data they're trying to send you. Sweet. Now that you've seen this API, I want you to promptly forget about it. Because like a lot of APIs, it's very low level, very good at what it does, but it's super tedious to use because it's so low level. So what most folks do instead is they use a higher level API, something like Socket.io. Socket.io is super cool. It's been around for a while. It comes in 2 parts. So one part is like the server-side part, and the other part is the client-side part. And it's cool because it's like its own protocol in a way. It starts with long polling, and as long as the browser supports WebSocket, then it'll upgrade the connection immediately, and you get the benefit of that. But if you're using something like Opera Mini, it'll still work for you. Comes with a lot of little features built in, like multiplexing and support for rooms if you're doing like a chat-based app. One of my favorites is auto reconnect because, again, I'm in New York City, and if you're, you have that WebSocket connection, you get in the subway, when you come back up, you wouldn't want to have to write the code yourself to reestablish the WebSocket connection, so Socket.io handles that kind of stuff for you. Now, there's 2 basic scenarios you're going to run into if you're doing this kind of thing. And the first is if you can guarantee that all changes to data will occur through your API, the API you're exposing to the public internet, say. And the other case is perhaps a bit more practical as time goes on. There's going to be other means of getting to your data that maybe don't go through your public API, and so we'll talk about both of these cases. So in scenario 1, it might look like this. So basically what happens in the very beginning, what you'll do is you'll have the web browsers, just as they connect, they're going to establish a WebSocket connection in the very beginning, and that connection is going to stay open for the rest of their session. Then one web browser is going to do some kind of manipulation of data. They're going to do like a post, put, something along those lines, and they're going to change some data. And of course, what the web server is going to do to make that happen is use the driver to update persisted state. And you might be using an ORM, you might be using a driver directly. In either case, once you get the commit, the confirmation that the persisted state has been updated, you're good. In the web server, you already have that data, so you can then kind of send out the signal to everyone else, hey, here's the latest and greatest state, and you're done. That works as long as all the data changes are going through your API. But what if changes can occur outside of the API? Well, the recipe changes a little bit, but what you do, you still going to establish those WebSocket connections in the very beginning, and then some kind of change is going to happen. And you notice in this case, I don't have just one API, like a public-facing API, but I also have this database API. This is just the easiest way to allow the database to communicate with the web server. So once that change occurs, I need to have the database notify the web server that the change has occurred, and I could at that time send the latest and greatest data along to the web server, or I could let the web server just do its own thing, use the driver again, get the latest and greatest data. Once it has it, it can then emit the data out to the clients. This is what I ended up doing for my solution. Now, when you do this, you got to be careful with how you implement this particular part right here, the communication from the database to the mid-tier. And the reason is, imagine, as you all were voting, you could have potentially, hundreds, if not thousands of votes per second coming in, and you can't send that many HTTP requests from your database server to the mid-tier. It's just not going to scale very well at all, so you need to have a solution for that. And when you first think about it, like from a JavaScript background, you might think, what we need is a debounce here, but it's actually not the right analogy. You need grouping. I'll show you very briefly the difference. So here, is kind of what you would get if you were doing a debounce. So what I'm doing with this code is I'm declaring a variable, timeout ID, and then I'm listening for click events on the window. And I want you to think of the click event on the window more like an update occurring to data in the database, right? So when an update occurs, I clear the timeout, reset it, now we have a new one, and after 3 seconds, the timeout will finish and invoke the callback. So if I run this, and I'm clicking up here, I'm clicking many times. Now when I stop, after 3 seconds, we finally get a click, right? So this is a debounce. It's basically taking all the events that occur and waiting until the last one occurs, the span of time goes on, and then we do something to respond to the event. It's the wrong analogy because I do want to update more frequently than that. I don't want to wait until there's no votes coming in before I update the screen. So it's not exactly a debounce that I want. It's actually a grouping technique, and that looks a little bit different. So I'll show you this code here first. And there's two parts here. The first part is very similar. I'm setting up a handler on the click event of the window. Only this time I have a variable to record when the group starts, and then I can just take the event and do whatever I need to do with it, just record the fact that it occurred. But below that, now I'm going to set up an interval, and I'm occasionally going to check to see if an event has occurred and if the current date has passed like a threshold of time. So I'm defining the poll interval. We're going to check every 10th of a second, and then the grouping time is 2 seconds. So what I'm saying here is all clicks that occur within a span of 2 seconds, let's treat those as one click or one event, but we're still going to handle it at that point. So a little bit different. So if I grab this, let me do a quick. All right, so now, even though I'm clicking faster, they're still coming through, and if I slow it back down, it's just going to change how many click events occur within a span of time, right? So this is the kind of thing you'll need to do if you do this kind of implementation. All right, let me show you the code that goes behind some of what you saw on the web browser and some of what you saw on the web server, so you kind of get an idea of how this was put together. So the way I develop these types of apps is I break them into two parts, like the client side, in this case I use Oracle Jet, and then the server side, which is Node.js. So when you're working with an Oracle Jet-based application, it's going to set up a grunt-based build system for you. And so you're doing your work here in source, and then you run this build process, and it's going to create this web directory, which is like your application meant to be run. So inside of source, you have typical kind of single-page application, index.html, but you're doing most of your work here in the JavaScript directory. So the main file is what we use to configure require.js. And you can see, so the very first thing I would need to have done is like an npm install socket.io, so we have access to the client side of socket.io. Remember, it's two parts. So I put that in. I actually have to do it as a shim because socket.io is not AMD aware, but it works. Once I have that in place, require is aware of it, then I can create a module like this one. So this is my app socket module. So in the client side, everyone that went to the demo, this ran once for you. And it's important that it only runs once. You really only need one WebSocket connection per client. So what this is, it brings in Socket.io, it invokes it once, just points to the web server, and then I have this single instance that I use throughout the application from that point going forward. Now, where do we use this? Well, the page that most of you are looking at is this Super Cities page. That's the listing of the cities. And as you can see here, pretty basic page. We have a div, an H3, what's your favorite city, and then I have this unordered list. Now, there's a data binding here, so we're using a component called a list view, and the data source is Super Cities data source, and you'll see where that comes from in a moment. And note that item is pointing to a template, and this ID is actually down here. So for each list item in that data source, we're going to use this template down here. And this is just referring to some functionality defined, for example, in the parent view model, as well as properties like name and the number of votes that this particular city has. But if I come back up and show you the other half of this, which is the view model itself, you'll see, first of all, that I'm requiring in that app socket module. I've just renamed it here to IO because it's a little bit easier to reference that way. So within this view model, there are some handles. So like when this particular handle is going to fire when a user transitions their view. So if you went from the dashboard page to the cities listing, this function would fire. So I just use a standard AJAX call out to go get Super Cities. I do a little sorting here in the client side, and then I go to that data source, which is defined above, and I just reset the items in it. There's another one down here, io.on. So here is where the actual like push from the mid-tier to the browser occurs. So I'm saying IO on Super Cities change. We get the data passes, has the items, and then I can use that to, again, just update that data source. And, you know, with these types of applications, once the data model, or the view model in this case, is updated, then the view updates to reflect that current state. So that's the browser side of things. And in terms of the web server, the way this works, we have the index.js, which kind of kicks things in. So I'm using the database driver for Oracle, creating a connection pool, and then I'm initializing my web server. So as far as the web server, I'm using Express Static for static file handling, and I'm pointing it to that web directory. So this is that directory I was showing you a moment ago. When you run the grunt build process, it gives you your application ready to go, so you can just copy that over. And down here, I'm mounting the API. And note, I have two APIs, right? So one's that public-facing, and one's the database API. And I do this init here, and I pass the web server in the database side of things. And so you can see here what's happening inside of init. It's actually very simple, and it's almost exactly like what we saw on the client side, only here in the mid-tier, I'm invoking Socket.io, but the mid-tier version. And again, I just need this single instance, and I can use this throughout the application. So I'll show you a little bit later when we come back to kind of the communication part from the database to the mid-tier when I would use this. But once I have this, then I can then emit from the mid-tier to the client as long as they're connected already. Cool. All right, let's talk about bringing in the database. Now, myself, I'm from Oracle. Oracle database is the one I know. But these concepts apply to any database system. There's probably going to be equivalents. I just don't know what they are in the database that you're using. But you're going to need two things to make this work. One, some means of handling events, and then some means of communicating when those events occur. So within Oracle, the first thing I think people are going to think about when it comes to events are triggers. So I could have used one of two types. We have DML and system triggers. Of course, in this case, we're talking about people, casting new votes. So DML trigger on insert kind of thing. Could have looked like this. So here I'm creating a new trigger on the city votes table, And the communication side of things will come to next, but this is the type of trigger that might have handled the event. That would have been really bad. Can anyone guess why? Anyone? So, has anyone seen this slide before? I believe Ryan Dahl showed this at JSConf EU back in 2009. This is the cost of I/O. We're talking about CPU cycles for different I/O operations. So L1, L2 cache, super fast. RAM, still fast. We get to disk. We're doing a disk write. That's not so fast anymore, right? So the insert of a vote is already slow. It's a disk write. What's even slower? Network. Slower by a lot, right? So what you don't want to do is kind of tie in the overhead of a network I/O with a disk I/O. That's just bad. So the next thing I explored as I was looking into this was a tool we have in Oracle called Scheduler. And of course, you just use it like this to create a scheduled job. Maybe it's a PL SQL block and it's doing something awesome and it's going to run daily. This repeat interval is actually like a super flexible calendaring syntax that you can use. But one of the neat things about Scheduler is that you don't actually have to schedule a job that runs occasionally. You can schedule a job and then you can call it on demand. And the nice thing about that is it actually uses a background process to run the job. So it's kind of asynchronous. I could actually create a stored procedure to do the notification part to Node.js, and I can modify that trigger just a little bit to instead now use DBMS Scheduler to handle the notification piece. Now we've decoupled the disk write from the network I/O. This would actually work, maybe still not a great idea. We'd have to handle that grouping thing I was talking about before. The next thing I looked at was something I found in the database. It's advanced queuing. And this is like this really awesome framework for point-to-point or pub-sub type subscriptions. And they have this enqueue notification feature. So anytime you have a queue, one of the things you need to do is occasionally find out if there's new things in the queue. And one way you can do that is to poll the queue, but polling generally doesn't scale, so they have an enqueue notification feature. For my use case, though, this feature was just overkill, so I didn't go there. And luckily, I came across this really awesome feature. I've been, at the time, using Oracle for over 10 years. I had no idea this was in there the entire time, but it's a feature called continuous query notification. So this is what it kind of looks like from a high level. I'm declaring a variable. This is the PL SQL API. I'm declaring a variable called registration info, and then I'm initializing it here, and I'm pointing it to, note it says callback. This is like a stored procedure. Right, so callbacks have existed in Oracle for a very long time, and here I'm saying, all right, we're going to start a new registration, and then I'm going to open a cursor, and I'm just selecting some data from tables. Now what I'm not doing is executing the cursor. I'm simply opening and then closing the cursor, and that's enough. I can then end the registration, and at this point, Oracle is going to monitor the result set of that query, and if the data changes, it's going to invoke the stored procedure that you specified for the callback. So this is very cool, and that's what I ended up using for my implementation. All right, so now you got the event side figured out. What about the communication side? So we've had, for the longest time, all kinds of packages, PL SQL-based packages that allow us to communicate out low-level stuff like TCP, HTTP as well, email protocols. I didn't use any of those because there's another package that is part of this like application framework within Oracle called Apex. And they've made it super simple. I'm sure they're just working on top of like probably HTTP. But if you're doing a REST call, it's definitely the go-to package in Oracle database. So here you see an example, the implementation now of notifying the mid-tier. So I'm simply saying make Apex Web Service, make REST request, and I point it to the Node.js server, tell it it's a get method, and really that's all it takes. I could send the data along, the updated data, if I want to avoid the mid-tier from having to come back and get it with the driver, but in this case, that's all I was doing. So I'll show you very briefly sort of the code along these two sides. And what I do, first I just create this blank user. The important part here is that your user does need some permissions in order to use the notification service. And also important to point out, if you want to communicate with Node, at least from within Oracle, it's kind of like Oracle's been hardened by default over time, and so you do have to kind of open up the network ACLs in order to allow that communication to happen. So once you have your user set up or created, you can then just create your object. So the first thing I do here is I install a package called Logger, and you can get this in GitHub. And it's just a really simple logging utility for Oracle, but it's important because I was running into bugs, essentially, that were occurring, but they were occurring asynchronously because it was this callback thing, and I didn't have a means of getting the error. So this is a tool that makes that really easy. It can catch the errors, and you can find out what's going wrong. So then we just create the two tables, insert all the cities. And then here's what my notification code actually ended up looking like. So here's the callback to the PL SQL procedure, which is defined below. But what I want to point out is this right here. There was actually already a feature in here for this kind of a grouping thing. And what this is saying is we're grouping by time. And I found it would only go as low as 1 second, but that was fine for my use case. So that was nice. I didn't have to build any logic for that. But then I just say the query I want it to listen for changes on, and then here's my actual notification. The only real difference that you're seeing here is that because I'm calling HTTPS, I had to create a wallet. It'll verify the SSL cert, that kind of thing. And here is where I'm using Logger. So this is the function, or the procedure rather, that's being invoked asynchronously. So if an exception occurs, then Logger is going to log out whatever went wrong, and this can really help in the debugging process. Cool. So the next thing I want to just point out, like, if you were seeing all that PL SQL code and just kind of feeling, I don't know, a little nauseous, I get it. I'm with you. What I want is something more like this. And this goes back to that safe harbor slide, but this is what the future could look like. Actually, the near future. We have a new version of our Node database driver coming out very soon. So once that's out, adding features like this will be a little bit easier. So forget about all that PL SQL code. This is how it could look. We bring in the driver, and we use the driver to get a connection to the database. And then we say, connection, create subscription. And here you're seeing a callback, but rather than like some PL SQL stored procedure, this is just a JavaScript function that's defined below. And then here, we see those same parameters for, like, you know, grouping by time and, you know, the amount, 1 second. So again, you wouldn't have to do any manual implementation there. But once you've got your subscription, you got that, and then you can go ahead then and register the queries you want it to listen for changes on, and when those changes occur, it'll invoke your handler. And so in this case, you just get a connection, get your latest data, and now you're seeing that IO emit. And so this is the event I was listening for on the client side, right? So we're emitting from the mid-tier to the clients this event. I'm just kind of doing a little namespace here. And then the latest and greatest data going out across the wire. Cool, so that's all I have, actually. I do have a couple next steps here if anybody's interested. Just some links if you're interested about learning any of the technologies across the tiers that I touched on here. You can get into any of that. Are there any questions? Absolutely. So the question was, will I share the presentation? Both the presentation as well as the code, if anybody's interested in that as well. Any other questions? All right. Yes? So the question was, how does the authentication part work? So in the very beginning of starting up the Node.js server, I'm creating a connection pool. And so once that pool is set up, it's already kind of authenticated to the database using a specific user. And if I needed to authenticate end users of the application, I would probably do that another way. But we didn't need that in this case. But once that's done, it's already taken care of, and the connections are ready to use. Any other questions? All right. Thank you all very much.